This is awesome. I'm so excited to be here. Thank you, Federico, for joining us, and thank you, Atomico, for having us. There's so much we could be talking about today, so let's get on with it and see how much we can fit in the next 20 minutes. One of the items highlighted in the report is the contraction of industry. And then you think about on the heels of the pandemic, where everyone started relying so much more on technology. And compute has never been in higher demand than now. Microprocessors. If you zoom into the computers, the internet, the computers inside the microprocessor, and we all, as business leaders, are so reliant on the work that you helped develop. And I know that's especially true in my field in artificial intelligence and how much we rely at DeepMind on the potential and the power of compute. So before we go there and talk about it, let's go back in time. Federico grew up in northern Italy. So let's go back to northern Italy and your childhood passion for planes. Could you tell us, Federico, how did that lead to your career journey?
Well, I was 11, and I love airplanes. How can they fly? I couldn't tell. And then one day, I was in a field playing with the kids, and I see a man, charging up something, and then this model plane flew, and I was stunned. I didn't know that a toy could fly. I thought that only the big planes could fly. So, it was a revelation for me to realize that you can actually make a toy that flies. And that was, it was an instant love and a passion. I bought myself a book. I didn't have enough money to buy much more than a book. And I learned how to do that. And by 12, I had my first model plane that flew. And basically, I realized much later that by 12, I had understood the process of invention, because I couldn't buy the kits, where they're all, you assemble something that is already, made for you. But I had to, first of all, imagine the plane. And so instead of studying Latin, I would draw my model planes that I was going to build. Then you had to figure out, put a plan together, buy the material, make the parts, assemble them, and then enjoy the results. So for me, by the time I was 13, I knew how to create products. And that has been a guiding star for me. I still build and fly radio control now in model planes. So
That's wonderful. I was going to ask you about that, actually. And that element of building is interesting, because as I was preparing for today, I learned that you helped build an experimental computer in 1960-61. And it's really where you had to work with transistors, and that also wanting to understand how did transistors work and how could you understand that took you to go back to school to learn about semiconductor physics or solid state physics.
Yes, that's right.
And you also described it as like your childhood was full of the Industrial Revolution and Agriculture Revolution. And this building and this wanting to understand how things work really helped lead to the digital revolution,
yes,
the industrial information revolution. So now let's fast forward to that part of your life. You were sent over, as mentioned in the introduction, from Europe to the United States, Silicon Valley, for a 6-month rotation.
Yeah.
It's been a little bit longer. Yeah?
Yeah, it took, I'm still in my 6th month. Yeah.
Time works differently there.
That was 1968.
Yeah.
I was working for SGS Fairchild. Fairchild is the company that developed the planar process, which was the first real process that made possible to make integrated circuits, because for the first time you could make many transistors on the same surface of a slice of silicon, single crystal silicon. So then you could easily connect them together and you had the integrated circuit. So that was 1960, 61. The first integrated circuit was sold in 1962. and I joined Fairchild. And at that time, the MOS technology, which is what now almost everything is built with that technology, was a kind of a Cinderella. It was just up and coming. And I saw the potential of changing the process, the manufacturing process, in a radical way, using polysilicon for the gate electrode instead of using aluminum. And that had a number of benefits. And I developed at that time the silicon gate technology, which was a new way to make integrated circuits, which then became the only way to make integrated circuits. At that time, 95% of all IC used bipolar technology, which is a different way to make transistors.
It's really amazing that you were able to develop this new technology of the silicon gate. And then you actually had a chance to apply it in a highly complex situation. And that actually with Intel. So for those who don't know, and Fairchild was one of the company that birthed a lot of what we now know as Silicon Valley. So then you went into Intel.
Yep.
And we have figured out that our Intel connection, I was 2 decades after you and 50,000 employees later,
Yep.
Working on the Pentium processor, but you had the first processor. So
Yes.
maybe you can tell us, how did you move from working on that gate technology then into Intel? And how did you, a boy from northern Italy who was interested in airplanes, be the person, the inventor of the first microprocessor?
Well, it was actually because I did all the pieces. I developed the basic technology that made it possible, the silicon gate technology. When I was 18 and 19, I built a computer and designed 60% of the computer. And I had 4 technicians working for me at Olivetti in Italy. Then I went to university, study physics, solid-state physics. So now I understood how to make transistors because I wanted to understand how they are made. And then I developed the best technology for making that. Then I wanted to make the most difficult circuit with that technology. Intel took that technology from Fairchild. They were founded on the technology that I developed. And Intel had the project for me. They had a project sitting there, which was a architecture of making a computer on a chip, but nobody knew how to do it. So I had all the pieces to be able to do it.
And it was
in 11 months, I did it. And you've seen the picture before. There was that integrated circuit that you saw. It was my chip, and on the upper right corner there was my initials, FF.
signed like an artist, because it was a piece of art.
Yes, it was a piece of art.
Which actually, we were talking about this earlier, you brought a multidisciplinary approach, right? You had done all of these different parts. Where and how do you think that your European background helped to influence that?
Well, I think is this more holistic way. I mean, in Italy especially, we're not as specialized as we are in the U.S. And so people, and also we learn more of the basics, and then we can figure it out by having more solid foundation of math and physics and so on. So when I graduated from University of Padua, I could do anything. I mean, I just, throw me anything, I'll do it, because I could find my way through the various technologies that were needed and just do it.
Well, and it's interesting because at Intel, you launched many microprocessors.
Yes, all the first 4s, yeah.
And you not only introduced these, helped design and launch the technology, but you also pushed business plans. Do you want to mention something like that?
Basically, the 8080, which was the first high-performance microprocessor, which it was 6 times more faster than the first 8-bit. It took me 9 months to convince my management to let me do it. Not only did I think about it, architect it, I wanted to do it, but it took me 9 months for them to actually, say, okay, do it.
Well,
so I did it, and then I decided that was enough, because we're going to lose the leadership in the market if we keep on losing time because we don't believe in the direction, which is microprocessors. Intel, by the way, was started to make memories, and they thought the microprocessors were a good way to sell memories, but they had not seen the potential of microprocessors. And so I pushed management to actually go out with chips that were initially custom designs exclusive for a Japanese customer and one for an American customer.
So you, again, your multidisciplinary approach of actually seeing the business opportunity.
And also the vision that was the future. I mean, clearly software has to replace hardware. It was too hard to make big systems. A new system for a new problem where you can do software much faster. It can also change, adapt, and so on and so forth. So for me, it was that way. But that was a major risk for me because I was a techie. I was not and I did not. My father was a professor of philosophy and history, and so I did not live in a household where people understood business. So for me, making this step and becoming an entrepreneur was kind of hard.
So maybe we can make that. You did go from being an entrepreneur inside of Intel, and thank you very much because my career would not have been possible if it wasn't for you, to being an entrepreneur.
Yes.
So you left Intel and went to found a company,
yes,
Zilog.
Yeah.
And you started to compete. You compete with Intel
Yes.
at a lower price point, and you did pretty well.
Well, but now at a better product too.
Of course you did. And in fact, it's still being manufactured today.
The Z80, I don't know, if there are gray hairs, probably some people here have used the Z80. How many people know about the Z80?
How many people played on a Pac-Man machine? Yeah?
On a Spectrum XX, okay, few. Anyway, the Z80 was a very, very successful product, introduced in 1976, and is still in high volume production today. So
amazing.
It's amazing. Mostly is a part of a system on a chip, but it's still.
So we're talking about the challenges of year to year, and here is an entrepreneur who, decades later, his product is still in mass production. How was it being a founder? And in fact, it wasn't. They mentioned in the beginning it wasn't the only company you founded. You went on to Synaptics. And,
I found 3 companies. Yeah.
Yeah. So how was it being a founder? And maybe you can talk a little bit about shifting from that entrepreneur to an entrepreneur.
It was intoxicating. It was hard, and I got the most personal growth out of that because, when you develop a product or you're a technologist, you solve problems which are solvable because you can logically get to the solution. But when you have to decide whether you make a product or not, you have to use your intuition because you don't know what the market is going to be 3, 4, 5 years from now. So how do you make that decision? So you have to change gear. And I realized that I always had intuition. In fact, inventors invent because they are intuitive. They invent because they can see they can see something completely, and then you got to do it. You got to build it. But you had to have the vision first. If you don't have the vision first, what are you going to do? You can try? No. And so learning to trust my intuition and learning to trust my gut, those were absolutely the most important steps that I made. And they led me to now study consciousness, which is a completely different beast. And I love it. I really love it.
Yeah, it's you seem to have always challenged yourself to learn more along the way. So I want to maybe you can tell us a little bit as a being founder. I also was reading an interview with you, and where you mentioned it also was the challenge of being a founder. So what was harder, the people or the technology?
By far the people. And learning how to build a solid culture in a company. I really succeeded in my 3rd company to really create a strong culture, a culture that allows people to get the basics of what it means to continue to innovate, not just the first product or maybe the second, but continuously innovate, renew yourself, rethink what you're doing. The 3rd company, which is Synaptics, is a very successful company. The other 2 were successful, but not nearly as much as my 3rd one, because I understood how to build a culture. And I understood that because I had to build my capacity to understand over the years. So.
And synaptics, maybe you could, it was mentioned in the beginning that it was about touch screens.
Yeah.
And did you know that technology, did it?
No, touchpads first, then touchscreen, yeah.
And did you have any idea how the microprocessor, how the Z80, in your work at Intel, the Z8 and Zilog, how touchpads would influence the world today?
Well, yeah, but not to the extent that they did. I think, for example, the touchpad, for example, we had, the first idea was there was a problem. What is the problem? The trackball. If you use the early laptops, the point on the screen, you use a little ball that you would move with your fingers. The fingers always have little grease, so after a little while, the ball is greased up, and it slips through the little wheels that they had to make to rotate. So you move the ball, and the and the cursor zip through, and so you had to open it up, clean it with alcohol, and and go back to work, and that's really a mess. So I challenged our best engineers to come up with a solid state solution. So I started meeting with them once a week, sometimes even twice a week, to brainstorm how to build a solution to this problem. And within 2 months, we had invented the touchpad and the touch screen. Just how to do it, the whole thing, and then of course was doing it, which took another year and a half. But the basic conception, was done at that time. The touch screen clearly was a solution in, looking for a problem. And then about 2000, 2001, I wanted to have a sample of a touch screen and go to different companies, telephone companies, cell phone companies, showing the touch screen. Say, if you use the touch screen, you can have more flexibility. You can avoid having a keyboard, and the whole thing is screen. They were laughing at us. Nokia, Motorola, RIM. They were so proud of their keyboards. Man, our keyboards is so good. What, you want to replace it with this thing? I said, well, yes. and then we ended up at Apple.
Yeah.
We showed the thing. They said, yeah, we like it, but we want the exclusivity. So I'd say no, right? And Apple did their own. In 2007, the iPhone came out. And when it came out, I said, that's it. We are second source of the rest of the world.
Yes.
And so the company at that time was about $300 million, sales a year. And then within 5 years, we were at 700 million. So,
it's really
because we were supplying touchscreen to everybody else. So.
That's awesome, and I think it also shows your kind of courage to say no when you needed to say no, and
absolutely.
have the conviction.
We would have been killed.
Yeah. So I only have time for, unfortunately, one last question. So maybe I'll pick off of the last story that you told us, which is you've done so much. Like everyone here owes you so much for what you have enabled in our companies and our lives. I wonder if you could go back from your information revolution, pioneering work that you've done back to that childhood time. If you could teleport back to northern Italy to your 12-year-old self, what would you say?
Atta boy.
Wonderful. Yeah. I think there's no way better to end that. Attaboy, thank you for your courage, for your pioneering work, for willing to take risks, for embracing the failure and the learning along the way, for role modeling what leadership is about, of continuous learning in yourself, investing in yourself, your teams, your culture, and for making so much of today's world possible. You have brought the future closer to all of us. Attaboy.
Thank you.